Hello and a heartfelt welcome to How to R. This is Mike, and today we're going to talk about working with data and data frames, accessing them, getting summary information about data in them, and stuff like that. So first, the question is, what is a data frame? So it's a question mark data.frame, and it pulls up the help file. And data frames are tightly coupled collections of variables which share many of the properties of matrices and of lists, used as the fundamental data structure by most of R's modeling software. And it is true. In your mind, just picture a table. Like in Excel, you would see this sort of, spreadsheet. You can really imagine it just like that. It has columns, and those are variables, and the rows are observations. That's the traditional layout of a data frame in R, and that's how you can think about it. All right, great. So let's go to a website and download some data, because we're going to learn how to read data into R so that we can then use it and begin doing data analysis. So let's go to a website. It's archive.ics.uci.edu/ml/index.html. And this is a repository with lots of common data sets. The one we're going to use is called Iris. It's right here. You can see on the screen. So go ahead and click on it. And we are going to go to the data folder and download iris.data. So let's look at it first real quick. Notice what it looks like. A row, and each element is separated by a comma. Okay? And it just goes on all the way down. Okay? It's not a huge data set, but it is a very commonly used one, and that's what we're going to use. Also notice there are no names at the top. So where do we get those? Well, Iris names gives us some information. So we're going to go ahead and copy that. Oops, copy some information about them, because we're going to use that a little bit later, so go ahead and copy. But let's go back and right-click Iris Data, save link as. And we're going to change the extension to a text file, or you could do even CSV, because we know it's comma separated. So it's simply a text file. We already know that. So you can safely get rid of the data. I'm going to save it as a CSV this time. It's going to ask me, are you sure you want to do that? Yes, because we looked at it and we know. So use CSV or text. Either one's fine. Doesn't really matter. All right, so let's go. Remember, we already got the names and copied them. So let's go back here. And we're going to start by doing a couple things. First, let's call it iris1, and we're going to use a function called read.table. Let's look at that over here in our help file, read.table. You see there's a bunch of options, so let's just hit read.table. And you see here, read.table is a very basic function, and there are different versions. There's read.table, which is the it's the broadest, the most general. There's read.csv, read.csv2, read.dlim, and read.dlim2. CSV, the default separator of data values is a comma, as shown here. Read.csv2, it uses a semicolon. Read.dlim means it's tab delimited. This little slash and T, that is how you denote tab. And read.dlim2 is also tab delimited with some other options. But we're going to start with read.table, and I'm going to show you a cool function here, and it's called, let's look at hit tab here and look at our options. Let's go to file and put in the function file.choose and then two sets of parentheses. File equals file.choose, two sets of parentheses. All right, and then let's go ahead and run that, see what happens. You should have a a Finder window or a file browser that comes up, and you can navigate to where you saved the file. I saved my file on my desktop. There it is, iris.csv, and you go ahead and just click open. And what it does is it takes the path, puts it into file, and then reads it in, and now you have, right here you see data called iris1, 150 observations with one variable. I'm up here in the workspace. And that's pretty nifty. So that's a cool function. Let's go ahead and see what that does. file.choose, what it does is it lets you pick a file, and then, oh, where'd I go? Sorry about that. I have no idea what just happened. Oh boy. Now it's going to start going really slow. Okay, sorry about that. And then open, and what it did was it just gave you the file path, and it read it in there. So that's a really handy way to find the path to something if you don't know how to get to it, or if you don't want to bother copying and pasting other things. You can do it right from R. Pretty handy. All right, so let's look at the read.csv function. All right. Oops, what am I doing here? File.choose. Let's do that again, and we'll call this iris2. All right, we get the same option. I'm going to go here. Okay, and it read it in. Okay, let's look at that. Let's see what that looks like. So let's do summary iris2. Summary parentheses iris2 close parentheses. All right, and so summary gives us some information about the variables. The minimum, so it gives us the quantiles, gives us the mean of each one, and also if it's a categorical variable, it gives us counts of each category. But wait a second, this is 50, this is 50, this is 49. What happened? Because we know it's supposed to have 150 observations, so why are these different? Well, if you look at the names of the variables, it assumes, if you look over here at read.csv, the default value for header equals true. It's true. And that is an issue because what you're saying is the first row in this data set is actually the names of the columns. But they weren't, and we knew that, so that's a problem. So we're not going to be able to do that way. So let's do header equals false, and let's run that again. And you know, actually, because we know where it is, it's really, if you have the path, it's a lot easier just to go ahead and use the path. So notice I didn't put file equals because it knows that it's going to mean file. You kind of have to pick and choose when you're going to use the actual arguments. It's safe always to just put in the argument name and then the value. But there we go. So let's try it again. Header equals false. And if we run that summary again, you'll see it just assigned these generic variable names. And indeed, we have all the variables in now. Excuse me, all the observations. All right. So summary of that. Now, how do we actually assign names? Well, there's a function called names, and you can assign names using that function. Let's paste. Oopsie. Let's get those names again. I went over it. Okay. Here are the names of the different variables. Okay. All right, to comment these out, you can highlight them, and on a Mac, hit Command-Shift-C, and on a Windows machine, Control-Shift-C, and it automatically comments out all the lines that you've got there. So we did that just so we can see what we're going to name these things. And to name them, you put the object in the function names, and then you assign it a vector of names. And so you need to quote these. So the first one we call sepal.length, and I'm capitalizing the first letter of the name and separating the first letter of each word in the name and then separating by a dot. You can't have spaces. That's a gotcha. You can't have spaces in a name in R or in a character, or excuse me, in a name for an object. Okay. All right, we'll call the second one, it's supposed to be sepal.width. And then petal.length, and then petal.width. And then the final one we'll just call species, because those are the different species of irises. All right, and then go ahead and do that. And let's just verify that the names turned out like we wanted. So you can do that by using the names function, but this time not assigning anything, and just putting names, parentheses, the object. And there you go. The names just like we put them in and expected. Fantastic. Alrighty, so let's run the summary again. And there you go. You see that the median sepal length is 5.8. The third quartile petal length is 5.1. There are 50s of each of these species, and so on. So that's some great information that you now have access to. Some other ways to access names is the function called colnames, C-O-L-N-A-M-E-S, iris2, and that will specify which names. So the names function defaults to the column names if it's a matrix or data frame. If it's a vector, there's only one dimension. But you can specify colnames with the object name C-O-L-N-A-M-E-S, parentheses iris2, and that gives you the column names. Or you can see rownames, iris2, and it's R by default names the rows with numbers. So there you go. Those are other ways to name things. And we could rename the rows if we wanted. We have no reason to, so we won't. But you would use the same syntax where you put row names, the object, and then assign it names this way. But it would have to be the same length, so it would have to be 150 item long vector. Alrighty. So the next thing, you'll notice here that you can use the tab feature in RStudio. So let's hit iris2 $, because that means we're trying to access a name, right? It's the name operator. And then hit tab. And now we can access all the objects within this object that have names. So the variable sepal length, sepal width. Okay, and there are lots of different ways we can do that. So let's just do sepal length. So there we go. And there's now a vector of all the sepal lengths. And let's name that first variable. Iris2 $tab sepal length. Okay. Whoa, what happened? Error, unexpected symbol in first. That's another gotcha. You can't have numbers as the first character in a variable name. So we'll call that something else. We'll just call it SL, short for sepal length. All right, so SL. And that's what we named it. Now, before we move on, let's look at one last feature that you can use on, or function that you can use on data frames. It's dim, D-I-M, and go ahead and put in your data frame iris2, and it tells you the dimension. So the first one is rows, number of rows, and the second one element is number of columns. So this is a 150 by 5 data frame. All right. So you can also use the summary function on vectors. Let's see what that does. In summary, if in doubt, use summary, because a lot of functions give output for an object if you use summary. So let's see what happens. It gives you the minimum, the maximum, the quantiles, and also the mean. You can also use the function mean to find the mean value. And it doesn't happen here, but often enough, the mean function will return a different value than the summary mean, because the summary mean uses more rounding. So use the mean function for actually calculating the mean when you're doing important work and not just trying to get an idea of what's happening. You can also do the median of SL. All right. You can find the max, the min, or the minimum. You can also see how long the vector is, length, SL. Okay, those are all interesting things. All right, so let's get a little more sophisticated in indexing. I've talked about indexing in another video. Feel free to look at that. Intro to basic functions. And we're going to do a little bit more advanced, a little more sophisticated indexing here. And it starts with a function called the which function. And you use relational operators. So which, and then the first argument is the object. So which in SL is, say, equal to 5.1. Let's see what happens. That returns the element numbers, so the indexes or indices of all elements which have the value 5.1. So the first argument is what object we're looking at, and then what is the logical operation we're performing, and here it's is it equivalent to, and then the third thing is what is the actual value that we're comparing to, and here we're asking which in SL are equivalent to the value of 5.1, and it returns those element numbers or indices, and that's what it is. So you can do other things like which in SL is greater than 5.1. Okay, a whole bunch are. All right, and which in SL are less than or equal to 5.1. Okay, fewer. All right, and you can also say which in SL are not equal to. So an exclamation point and then an equal sign is the not equal to 5.1. And obviously there are even more that are not equal to 5.1. So those are very, very useful. You can also do, there's a specific function called which.max. So which.max in SL. So it gives you the element number or index of the maximum value in SL. So this isn't the actual value, it's the index of the value. So to actually access that, we use our indexing, right? So the square brackets, which.max SL. And notice I'm using a function within these brackets. You can do that, and that's part of the power behind a scripting language. All right, so the actual value is 7.9, but the index number is 132. You could even assign that index a variable. Let's say max.end. Let's call it that. Okay, and then access that variable, or access that element. Okay, it gives us the same thing. And that's a useful way of going about doing it. All right, so now let's go into indexing an actual data frame. So let's look at iris2, and let's say it does it. Here's how it works. So there are going to be two parts now. There are two dimensions, right? The row, which is the first element in this bracket, and then a comma, and the second one is the column, right? So the first part here is the row, and the second part is the column. So let's say you want to see all, and by the way, if you leave it empty, so if you have to have a comma there, but if you leave it empty, it just means show me everything. Okay, so there, it says show me everything. But let's say we want to look at only the fourth column. We can do that. It says show me all rows of the fourth column. What if you want to look at, the first 10 rows of all the columns? That's a useful way of kind of getting an idea of what the data looks like. I do that often. You can do the negation, right? So you can say show me the first 10 rows of every column except the fourth. You can do that as well. Or you can say show me the first 10 rows of every column except the first through the second. Okay, it does that as well. Show me the first 10 rows of only the second and fifth column. Okay, so you can also access within these brackets, you can access by name, but the way to do it is you have to put the name in quotes. So sepal.width, for instance, and it shows you all the values in that variable. So you could say, oops, I guess I had an object named iris. Interesting. Oh, okay. And then you can access the first 10 of the same variable. There we go. Anyway, so that's how you can index. And if you had row names, you could do the same thing with the naming the actual row you're trying to reach. And you can do the same thing like this. So now let's say we're going to now grab a subset using the conditional which function, okay? So we're going to say show us all rows where the sepal width, we want to see all of the observations where the sepal width is equal to 5.1. Okay? And the reason we could do that is because remember, SL is simply this variable pulled out as a vector. And so the index numbers work here, and you have to be careful about that. So let's do that in a couple steps. We said SL, let's name which SL equals 5.1. Or let's say this, let's do our greater than 5.1. So let's say SL greater than 5.1. So SL capital G capital T 5.1 is going to be assigned to those, so those indices are going to be assigned to that variable. All right? And we can go ahead and verify that that's going to work by looking at SL. And these are all, they should all be greater than 5.1, and it looks like they are. Okay. Now, let's go ahead and look at all columns of value of variables. Excuse me. Let's look at all the columns. So we're going to leave the second part blank. Okay. And now we're only going to access those observations where the flower had a sepal length greater than 5.1. So we do that by saying SLGT5 because we already found those indices. Okay? And there we go. We have that. All right. So one last thing, and sometimes it's useful to put data frames in lists, and we can do that pretty easily. Let's call it big iris there, all caps, and we're going to make a list, so list parentheses, and then just each item you want to put in that list. And we'll go ahead and name it. So we'll say iris1 equals iris. Let's take a step back. First, let's take the first 100 elements of iris2, okay, and keep all the columns, and we'll name it I2. Or excuse me, we'll name it I1. And then we'll name I2 the last 50. So 101 through 150. Okay, that's, oh, excuse me. So see, this is actually good. We got an error, and the reason is because I left out the comma. And so it doesn't know what to do because this is a two-dimensional object, but we're only giving it one dimension to index through. So we have to add that column in, or comma in. Okay, so now we have two new data frames. You'll notice up here in your workspace, one is 100 observations, and the other one is 50. And let's say iris, all caps, is a list, so list, containing, and we'll name it iris. We'll say iris1 equals I1, comma, iris2 equals I2. Just like that. And now we have a list. Look over here in our workspace, and you see iris is a list with two objects in it. And you can work on that just like you would work on anything else. You can access it by saying, give me the first. Now notice the double square brackets here. First thing is going to be that data frame, right? And you can even say, well, what's the dimension? Like, how do I know which one it is? And it's 100 by 5. You can do a summary, just like you would on a data frame. You can even access So now you've accessed that first thing. So pretend once you access it like this using the double square brackets, now you can use the element name operator and tab and access a single thing. So show me all the species there, and there you go. Or you can even use the name operator. Because we've named the objects in the list, we can use the name operator on the list itself. So $tab, look, there they are. So let's access the second one. And so now we're in this second, the inner object. We're in that data set, and so we can use the name operator yet again and access petal length. And we can even run functions on it. What is the mean of that? And there you go. So there are lots of different ways you can access objects or things in lists and in data frames. Hopefully this has been useful. I'm sure it has been. I would love to hear any comments or questions, so put them down in the comments section, or just let me know what you're thinking. This has been How to R, and have a good one.